loss of exponents or loss of indices. So these both are same. So especially in this topic I'll explain you around 8 important laws. So these laws if you know perfectly, then easily we can solve the numerical sums. Fine, the one by one I'll explain you briefly. First of all, let x be any rational number. So x I am taking any rational number, and we need to take some other numbers. Let m and n be any positive integers. M comma n are positive integers. Then only we can follow some laws. So first of all, if, for example, if I write some 2 to the power 5, this is a exponential form. So here this 5 we can call power or index. Then this 2 we can call it as the base. So if I write x to the power n, then n is the power and this x is nothing but the base. No, or else minus 2 to the power all to the power 5. Now here minus this 5 is the power and minus 2 is the base. Right? Only for example if I write minus 2 to the power 3, that means power 3 only for 2, not for minus. So 3 is the power, only 2 is the base here. Or else if I write some 2 into x power 3, 2 into x power 3. So 3 is the power, only x is the base. So not 2. So 2 will not take because 2 is something but coefficient here. There's a coefficient. xy 3 xy all power 3. So these both are completely different. So here if you observe in xy cube 3 is the power, y is the base. But here 3 is the power, x into y is the base. Because this power is for completely x into y. That's why this is called the base. So for which number the power is there, that one is the base. Here x is just a coefficient. Okay. This all further we'll see. First we'll see the loss. So first law, x to the power m, because already I take x is a rational number and mn are the positive integers. Then x to the power m into x to the power n. So if both exponential forms, if I want to multiply, here base is same. So x to the power m plus n. This is the first law. X to the power m into x to the power n is equals to x to the power m plus n. So whenever the bases are same, just we can add the powers m and n, just to add. If we take some example, 2 to the power 5 into 2 to the power 8. So we can write 2 to the power 5 plus 8. So 2 to the power 13, that is. Even negatives also. For example, minus 3 power all to the power 2 into minus 3 power 4 into again some minus 3 power 3 is there. So not only for two terms, we can take more than two also. Now minus 3 is completely base. We can add all the powers. That is 2 plus 4 plus 3. Right? That is minus 3 to the power 2 plus 3 plus 2 plus 4 plus 3, 9. So for rational numbers also same example. 2 by 3 whole to the power 2 into 2 by 3 whole to the power 6. So we can write 2 by 3 whole to the power 2 plus 6 is 8. This is the first law. Law 2. So it says x to the power m by x to the power n is equals to x to the power m minus n. So here one is numerator and one is denominator, but bases are same. In that case we need to subtract the powers. So your condition is m is greater than n, because m should be more than n. Then we can take example 5 power 5 by 5 power 3. So you can write 5 power 5 minus 3, that is 5 to the power 2. Even you take negatives, minus 7 whole to the power 4 by minus 7 whole to the power 1. That means there is no power is 1 we can take. So minus 7 whole to the power 4 minus 1, minus 7 whole to the power 3. M is greater than n, I said condition, right? In case if it is not greater also, but power will come negative, again we need to reciprocal it. I'll give an example. Okay, for example 2 to the power 5 by 2 to the power 7 is given. 2 to the power, anyway first power minus second power, that is 5 minus 7 only should take, that is 2 to the power 5 minus 7 is minus 2 will come. Now this is like first formula, x to the power minus 1 is equal to 1 by x, as I explained previously, that is 1 by 2 power 2 we can write. This is only power 1, or else if you take x to the power minus a, you can write 1 by x to the power a. So that powers we can write as denominator to change it. So this is the second law it denotes. Now let us see third law. It says x to the power m. Yeah, same thing. Just I said no. If in case m is not greater than n, x to the power m by x to the power n is equal to 1 by x to the power n minus m. So this is when m is lesser than n. So if m is less than n, then directly we can take in denominator place x. See example 3 power 2 by 3 power 6. So this you can write 1 by, directly you can write in denominator place. Base is same, but instead of 2 minus 6 you can take 6 minus 2. Okay, 1 by 3 to the power 4. So finally we'll get the positive power. Fine. Now let us see one fourth law. So fourth law says x to the power m, again some whole to the power n is there, then we can write x to the power m into n. So if there is no symbol, just into it is product. So x to the power m whole power n is equal to x to the power m into n. So check example 3 to the power 2 whole to the power 3. Then we can write 3 to the power 2 into 3. Okay, these both powers we just multiply. That is 3 to the power 2 3 is 6. So finally answer is 6. Okay, let us take one more example. Take fractions also. Now 3 by 2 whole power 3 to the power 4. So we can write 3 by 2 whole to the power. So both powers we just multiply. 3 into 4. That is 3 by 2 whole to the power 12. Fine. This is the fourth law. Look, one more example. For example, the negative base, that means minus 1 by 3 whole square to the power 4. So this one minus 1 by 3 is the base. Okay. Then powers are 2 into 4. So if you multiply minus 1 by 3 whole power 8. Then you can split it. That means minus 1 power 8 by 3 power 8. So minus 1 power 8 is 1 itself because power is positive number. So negative 1 of the power positive means you'll get the only positive value by 3 power 8. So you can simplify. 3 power 8 means 3 8 times you need to multiply. That is 1 by, in power notation is 1 by 3 power 8, 6561 this is. So if you multiply 3 8 times. Okay. So this is the fourth law. Let's see the law of 5. Now it says, for example, x to the power minus m. If the power is negative, then you can write 1 by x to the power m. So we have seen in properties similar one. At the same time, 1 by x to the power minus m, we can write x to the power plus m. That means whenever interchange reciprocal that, then power sign will be changed. So just remember that way. So for a rational number p by q, if I take p by q, I said one property already. That means p by q whole to the power minus m. If you want this minus m to be positive, then interchange. That means reciprocal of p by q is q by p. Then power will be plus m. This is the fourth laws. Now this is one. Similarly, same thing. 1 by x power minus m is equal to x to the power m. So see example. 3 to the power minus 4. So I can write this is 1 by 3 to the power 4. That is equals to 1 by 81. Or else the denominator is negative power. That means 1 by 7 power minus 2. You can write 7 power plus 2. So if you take the numerator, second property, that is 49. Now interchanging the fraction, 5 by 8 whole to the power minus 3. Now power is, here is minus 3. So to make it minus 3 to the plus 3, we should reciprocal this 5 by 8. Okay, this 5 by 8 if you reciprocal, that is 8 by 5 and whole power plus 3. Then we can split 8 power 3 by 5 power 3. If they asked to simplify in the question, then 8 power 3 is 512, 5 power 3 is 125. So this is the fifth law, we can make like this. Let's see law number 6. It's very simple. So it says, if any number to the power 0, x to the power 0, that value is equal to 1. Okay, just simple example. Any number you can take to the power 0 is 1. For example, 5 power 0 is equal to 1, or minus 3 to the power 0 is equal to 1. Any number minus 4241 to the power 0, even though that value is 1. So not only this, you can take fractions. Minus 2 by 3 whole to the power 0, so is equal to 1. Okay, x to the power 0 is equals to 1. X is any rational number. So except 0, so 0 you can't take this. 0 power 0 is not 1. Okay, now this is the sixth law. Next, law number 7. So seventh rule, how it is. For two different numbers x and y, so 7th and 8th are important. For any two different numbers x and y, so if I'm taking 2 here now, then we can write two rules. X into y whole to the power m. So x into y whole to the power m, then you can write x to the power m into y to the power m. So that power m I can split for both, multiplying, or else x by y also whole to the power m. Then also I can write x to the power m by y to the power m. So that power value we can split to the numerator and denominator, where m is any positive integer. So m is positive integer. Okay, let us take example for this using these two properties. Example 6x whole square. So bracket is there, that means 6. For 6 also you'll apply power 2, and for x also you'll apply power 2. So 6 square is 36, and that is x square. So multiplication symbols you need not to keep always in this algebra topic. One more, for example 1 by 2 xz whole square. Now for each and every number or variable you'll apply the power 2. 1 by 2 power 2 and x power 2 and z power 2. So that is 1 by 4. 1 by 4 also you can apply. So minus 1, that means plus 1. 1 square by 2 square x square into z square. So finally I can write 1 by 4 x square and z square. Right. So this is the law 7. It says, let's see the one more last law in this, exponents and powers. Law 8. So it says if x power m is equal to x power n, if x to the power m is equal to x to the power n, then m is equals to n. So whenever the bases are same and two exponentials are equal, at the same time powers also must be equal. This it says. So your condition is x is greater than 0. So conditions we need important. X should be greater than 0. At the same time x is not equals to 1 also. I'll tell you why these two conditions also given. Let's see example. For example, x to the power So whenever the two terms is given, we can see this. For example, x to the power y is equal to x to the power z is given. So then compulsory that z and y should be equal. So y must be equal to z. So fractional indices. So this is a simple law. At the same time, we can see some fractional indices. For indices of the type 1 by n, x to the power 1 by n, I can write nth root of x. So this is also one of the rule we can remember for this laws. Fine, these are the important laws from this powers, exponents and powers. So let us see some more numerical sums from the same topic. So let us see some more example problems which are using these laws in different way. So how to simplify and all we'll see now.